A rock roughly half a mile wide may have just shown us that the asteroid belt is far more complicated than we ever imagined. And the craziest part? NASA wasn't even originally planning to study it. They were just running a test. This is the story of NASA's Lucy spacecraft, a mission designed to explore some of the most mysterious objects in our solar system, and how two early flybys produced discoveries that scientists never expected. Lucy launched on October 16, 2021, from Cape Canaveral. The spacecraft was named after the famous 3.2 million-year-old fossil discovered in Ethiopia in 1974. That fossil gave scientists an extraordinary window into human origins. Lucy is designed to do something similar for the solar system. Asteroids are essentially time capsules. Many preserve material left over from the era when planets were forming from dust and rock billions of years ago. By studying them up close, scientists can investigate how the solar system was assembled and how its materials moved around over time. Lucy is planned for a 12-year journey covering billions of miles and visiting multiple asteroids, including the mysterious Jupiter Trojans. These objects travel around the Sun in two enormous swarms near Jupiter and have never been visited by a spacecraft before. But before Lucy could reach them, the mission had two unexpected stops. The first was an asteroid called Dinkinesh. Dinkinesh wasn't originally the star of the mission. It was added as a convenient target because Lucy would pass close enough to observe it. Scientists planned to use the encounter as a rehearsal for the much more complicated Trojan flybys. Dinkinesh looked like an ordinary asteroid. It wasn't. On November 1, 2023, Lucy passed within roughly 270 miles of the asteroid and began sending images back to Earth. Scientists expected routine test data. Instead, they discovered that Dinkinesh had a companion. A small satellite was orbiting the asteroid. The companion was named Selam, an Amharic word associated with peace, continuing the connection to the Ethiopian Lucy fossil. But the surprise didn't end there. Closer examination revealed that Selam wasn't a single solid object. It was two separate bodies joined together. Scientists had discovered a contact binary satellite orbiting another asteroid, a remarkably unusual configuration and the first confirmed example of its kind observed up close. The discovery became even more interesting when scientists studied Dinkinesh itself. The asteroid had a massive trough running across its surface and a ridge around its equator. Those features suggested that Dinkinesh had experienced a dramatic episode in its past. One leading explanation involves the Yorp effect. Sunlight doesn't heat an asteroid perfectly evenly. Over enormous periods of time, that uneven heating can gradually alter the asteroid's rotation. Eventually, Dinkinesh may have spun fast enough for material to break away from its surface. Some of that material escaped. Some fell back. And some entered orbit. Over time, the debris may have assembled into two bodies that eventually came together to form Selam. In other words, Lucy wasn't just looking at a rock. It was looking at the aftermath of an asteroid reshaping itself. And remember, this was supposed to be a practice encounter. Then Lucy reached its second warm-up target. An asteroid named Donaldjohanson. The asteroid was named after paleoanthropologist Donaldjohanson, who was involved in the discovery and study of the Lucy fossil. The connection was almost perfect. A spacecraft named after Lucy was now visiting an asteroid named after the scientist connected to Lucy's discovery. On April 20, 2025, Lucy passed within roughly 600 miles of Donaldjohanson at a speed of around 30,000 miles per hour. The encounter was extremely brief. But the spacecraft managed to collect detailed images and scientific measurements. And once again, the asteroid wasn't what scientists expected. Donaldjohanson turned out to be an unusual contact binary, made from two large pieces that had come together. Its narrow connection between the two lobes created an unusual geometry that NASA compared to two nested ice cream cones. The asteroid is roughly 8 kilometers long, making it an enormous object compared with the tiny spacecraft observing it from just hundreds of miles away. But its strange shape wasn't the only surprise. Its motion was unusual too. Scientists found evidence that Donaldjohanson is not simply rotating around one stable axis. Instead, it is also tumbling. Its motion combines rotation with a second wobbling movement, producing a complicated state known as non-principal axis rotation. Imagine throwing a football badly and watching it wobble unpredictably through the air. Donaldjohanson is doing something conceptually similar, except it is moving through space. Then came another intriguing clue. Scientists detected iron-rich clay minerals on the asteroid. Clay minerals can form when rock interacts with liquid water. That doesn't mean there is liquid water flowing across Donaldjohanson today. The asteroid is far too cold and exposed for that. Instead, the minerals may preserve evidence that water once interacted with material in the asteroid's parent body. And that possibility matters because water is one of the biggest mysteries in planetary science. Where did Earth's water come from? Earth formed relatively close to the Sun, where conditions during the planet's early history were not ideal for retaining large quantities of water. One major possibility is that water-rich material was delivered later by impacts from asteroids and other bodies originating farther from the Sun. Scientists have already found evidence of water-altered minerals on other asteroids, including Bennu and Ryugu. But the chemistry isn't identical. Bennu and Ryugu contain magnesium-rich alteration products, while Donaldjohanson shows evidence involving iron-rich clay. That difference could indicate that these objects experienced very different histories. Different parent bodies. Different formation environments. Different amounts of heating and water interaction. And potentially different regions of the early solar system. That's what makes Lucy so important. The spacecraft isn't simply taking pictures of rocks. It is reconstructing the history of the solar system from physical evidence locked inside these ancient bodies. And so far, Lucy has already shown that seemingly ordinary asteroids can be extraordinarily complicated. Dinkinesh revealed an asteroid with a strange satellite system created from multiple pieces. Donaldjohanson revealed a bizarre double-lobed object with complicated rotation and evidence of past water-rock interaction. And these were only the warm-up targets. The real mission is still ahead. Lucy is heading toward the Jupiter Trojan asteroids. These objects are trapped near Jupiter's orbit in gravitationally stable regions called Lagrange points. Some researchers believe many Trojans formed much farther from the Sun and were later captured during the chaotic migration of the giant planets. If that is correct, these asteroids could preserve material from regions of the solar system that no spacecraft has ever explored directly. Lucy is scheduled to begin its Trojan encounters in the coming years. And that is where things could become even more interesting. The Trojans may contain primitive material that survived from the earliest stages of planetary formation. They could reveal clues about where water and organic compounds originated. They could help scientists understand how Jupiter and the other giant planets moved during the solar system's chaotic youth. And they may tell us whether the material that eventually became Earth came from nearby regions, or was transported across enormous distances. The most fascinating part is that scientists don't know exactly what Lucy will find. That's the entire point. The spacecraft's first two encounters have already demonstrated how dangerous it can be to assume that an asteroid is simple just because it looks like a rock from millions of miles away. Dinkinesh looked ordinary. It wasn't. Donaldjohanson looked like another small asteroid. It wasn't. Up close, both revealed complicated histories involving collisions, reshaping, unusual structures, and unexpected chemistry. This is one of the fundamental lessons of planetary exploration. The universe repeatedly punishes our assumptions. Objects that appear simple from a distance can become incredibly complicated when we finally get close enough to see them. Lucy is now carrying everything scientists have learned from these early encounters toward the Jupiter Trojans. Every new image will reveal another piece of the solar system's history. Every measurement could challenge another assumption. And every asteroid could contain evidence of events that happened billions of years before Earth existed. The solar system formed about 4.6 billion years ago from a massive cloud of gas and dust.